Hello everyone, this is day 8, question 2 of our Leetcode activity, power of x and n. So implement a function, power of x and n, which calculate x raised to the power n. That is, we have given the integer x, integer n, we have to just calculate x raised to n. So, but here n can also be negative, as you can see here x raised 2 raised to minus 2 is 2 1 by 2 raised to minus 2 1 by 4, which is 0.25. So n can be negative and x also can be negative. So both can be negative, but either x is not 0 or n is greater than 0. This is the given condition. And also here it is given that x raised to n will be from 10 raised to 4 to minus 10 raised to 4. But here you can see that it is given with decimal precision, so we have to use double. So we will take a recursive approach for this question. Here, first of all, we get our x and integer n, and we declare that a variable capital N and equal it to n. So we are doing this because if n is less than 0, that is n is negative. So if you remember your exponents, a raised to minus b is equal to 1 by a raised to b. So for example, b is equal to 2. So 1 raised to minus 2 is equal to 2 raised to minus 2 is equal to 2 raised to 2, which is basically 1 by 2 into 1 by 2. So by this by this rule, what we can do is, if n is less than 0, x is equal to 1 by x, that is a will become 1 by a, 2 will become 1 by 2, and n is equal to minus n. As n was already negative, n will become positive. You can see here this was minus 2, but now here it is positive 2. So 1 by 2, so that is 1 by x, and then we negate n, and it was already negative, so it will become positive. So if we have question which is 2 raised to minus 2, we have converted that question to 1 by 2 raised to 2, which is the correct mathematical form. Now once we have this, we return power x comma capital N. So what is our power function? It will take, if n equal to 0, we return 1, as a raised to 0 is equal to 1. So this becomes our base case. Our base case is n equal to 0, and for that we return 1. So now we calculate double half. So what is half? We now recursively call our power function again with the same x but n divided by 2. Now if n was even, we can just simply return half into half, but if n was odd, we have to return half into half and an extra x, that extra x which made that n odd. So in such a way, we'll recursively convert like half our n every time until and unless we reach n equals to 0, and then we will calculate the power of x. Now, for example, our question is n is equal to 2 and n x is equal to 2 and n is equal to 10. First of all, we'll go power to 10. We'll do n, again we will call power x n by 2. So 10 by 2 is 5. Again we'll call n by 2, so 5 by 2 is 2.5, but we take the floor, so this is again 2. 2 by 2 is 1, and again 1 by 2 is 0.5, but we take the floor, so we hit the 0, and this is our base condition. So here we will just return 1. Now for 2 1, 1 is odd, 1 is odd, that's why we will perform half into x. So what was half? Half was 1. This is our base case. 0, it will return 1. So 1 into 1 into x is 2. So now this, so this returned 1. This will return 2. Now again power 2 2. So 2 is even. So we'll just multiply half into half. Half into half was, what was half? Here this has returned 2, so half was 2. So this will return 2 into 2, that is 4. So again 5 will be half into x. So here it was 4 into 4 into 2, so this will return again 32, and at last 10. So that's half was 32. 32 into 32, this will be calculated as, so this will return 1024. So the logic is simple, as if x raised to e1, if x raised to e1, so n is e1, so we can divide it by 2, and we know the, we know can be written as 2 raised to n by 2, 2 raised to n by 2, if n is even. But if n is not even, we need to root a raised to n is n by 2, n by 2, and again into a. Why? For example, if this was 5, 5 by 2, so 2, 2, and again we need to add 1 to get to our 5. So this is the logic, this is the pseudo code, and this is how the actually recursive tree and how it will be calculated. So now we are reducing our n by half on each step. So if we remember from our binary search video, algorithm which divides or which reduces our input size or search domain by half on each step, the kind complexity of that algorithm is log n. As you can see, if n was initially n, and when do we stop? When only one element is remaining, or we get n equal to 0. And if we take k steps, so this will be the equation that For k steps, n by 2 raised to k should be equal to 1. So n should be 2 raised to k. Taking log 2 both sides, we can say log 2n is equal to k. So k was our number of steps for input size n, and that is what our complexity is, operations performed relative to our input size. So the coin complexity will be log n for this recursive approach. And if we take the iterative approach, that actually will turn out to be O of n, because for if it is 2 raised to 4, we'll apply a for loop, on each step we will multiply by 2, 2, 2. So that will be O of n. Thank you.